We are going to work on chapter 1 right now, and I am going to start with section 1.1. So what we're going to study in this section is the practice of statistics. So what is statistics? Define statistics and what is statistical thinking? What is the process of statistics? Explaining qualitative and quantitative variables, discrete and continuous variables, and then determining a level of measurement of those both types of variables. All right, so what is statistics? Well, it is defined as the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. So the first part of the class, we're going to work with that first part with collecting, organizing, summarizing. And then in the second half of the semester, we are going to work with that inferential or measures of confidence kind of things. All right, so any information that we look at or work with is called data. And data is facts that we use to draw conclusions. Data is going to describe the individuals or items we are looking at. It can be any variation of topic, whatever we want to look at. The biggest thing to note is that all data is going to be different. No two people or no two items are exactly the same. There are going to be differences between them. So there's going to be what we call variability of that data. We're going to have different answers for different people. So examples here, do you have the same hair color? No. Do you all sleep the same amount of hours every night? No. Do you consume the same amount of calories in a day? No. So what we're going to do is we're going to take all that into consideration, and we'll be able to figure out different things from the varying data. All right, so here's what happens in statistics. We have a population. That is the entire group of people that we want to study. So that could be the entire United States population. It could be children aged 6 to 8. It could be females age 50. You, as the researcher, decide what specific group of people you are looking at. That is your population. From that population, you take what is called a sample, and that should be done randomly. We will learn about that a little bit later. And in that sample, you are going to look at every single individual and ask them questions or run a test on them, however you're going to collect that data. Okay, so we have our population. From that population, we take a sample, and inside that sample is all the individuals that we are going to collect data from. Okay, once we have all of that data, we can then create statistics. So a statistic is going to be based on our sample. So statistic, oh, my pen's not working. A statistic is based on a sample. So statistic, sample. Those will be together, S. If you ever have a statistic, that value came from a sample. Okay, descriptive statistics are what we're going to work with first. Kind of talked about that here. It's going to give us our summaries, our graphs that you're used to, things like a bar graph or a pie chart, those kind of things that you have seen before. Things like mean, median, and mode, which may be common terms for you. And then eventually we're going to go to what is called inferential statistics. And that is where we take this information and we're going to kind of expand it further into the population. So a statistic is based on a sample. A parameter is a value for the population. So sometimes you have access to the entire population. When the United States does a census, they are accessing every single person in the population. So those values are parameters. If you've only taken a sample of people, you have created statistics. All right, so what does that mean really? So suppose the percentage of all students on your campus who own a car is 48.2%. This value represents a parameter because it is a numerical summary of the population. Okay, keyword here is you got every single student, all students on your campus. Oops, sorry about that. All, I took every single person. That is my entire population. So the value of 48.2% is a parameter. Now, however, let's say I was only able to sample 100 students on my campus, and I got a value of 46% own a car. Note, the values are going to be close to each other, but this value is considered a statistic because it is based on a sample. So if you access the entire population, everybody, you have a parameter. If you've only taken a sample, you have a statistic. All right, so how does the process of statistics work? What researchers will do is they are going to come up with something that they want to research. Maybe it's a question they want to ask, or they have a new product that they want to test or study. So they're going to create some questions that they want to answer, and then they're going to figure out who they need to survey and how they're going to do that. So the next part is they are going to then get that survey of people. They're going to figure out and collect all those people that they're going to study, and they're going to do the research. Are they just asking questions? Are they providing them with treatment? Whatever they're doing to get the research collected, okay? This takes time, this takes money, because you have to be very careful to make sure that your data is collected correctly. You want to make sure your results are meaningful. If you make mistakes along the way, you may have to redo the whole process. Okay, so we want to make sure our data is accurate. So it's going to take time and focus on what you're doing. All right, after you have all of your data collected, this is when the calculations start. Okay, so if you are going to do descriptive statistics, that is our chapters 2 through 4. So things like making a graph, mean, median, mode, correlation, those are things we're going to discuss there. Or are we going to perform inferential statistics? Okay, those are things from chapters 5 really to the end here. We go through chapter 11. So there's 2 different ways that we can kind of go based off of what we're looking at. We can do our descriptive statistics, and those can then lead to some other information to explain the entire population. All right, so let's explain the whole process for this question here. Trust your neighbor. Pew Research conducted a poll and asked, do you trust all or most of your neighbors? The following process allowed the researchers to conduct their study. So this is how they walked through the process. All right, so what is their research objective? Well, they wanted to determine the percentage of adult Americans who trust all or most of their neighbors. So they wanted to talk about adult Americans. So adult Americans is my population. Okay, collect our information here. It is unreasonable to expect to be able to survey the more than 200 million adult Americans in the United States. Okay, they're clearly not going to be able to access everybody. So they're going to create a sample, and they have to figure out how they're going to create that sample, how many they're going to sample. In this case, they got a sample of 1,628 adult Americans and asked them, do you trust all or most of your neighbors? Just answering yes or no. And they got 847 stated that they trusted all or most of their neighbors. Okay, so their sample was 1,628 adult Americans from the population of all adult Americans in the United States here. And they found that 847 trusted their neighbors. So what can we get from that? Well, if we take 847 out of 1628, that is 52%. So about 52% of adult Americans from our study here trusted their neighbors. That is a descriptive statistic because it is based on our summary of our sample. All right, what they can then do is move to the process of inferential statistics. And when you do that, what you do is you kind of create a buffer. We know that this is not going to be the exact value if I were to access everybody, every adult American. But what's going to happen is it should be close. If I provided an accurate sample, my result should be representative of the entire population. This is where we go into the whole inferential part here, and it may be a little confusing. I promise we'll hit it a lot harder as we get towards the second half of the class. So Pew Research wanted to extend the results of the survey to all adult Americans. When generalizing results from a sample to a population, the results are going to be uncertain because, again, we cannot access every single adult American. So what they do is they create a margin of error and can assess their results or adjust the results on a range of values to where they expect the full population value to fall. So they are 95% certain that the percentage of all adult Americans who would trust all or most of their neighbors would be somewhere between 49.5% and 54.5%. Okay, so what they're going to do is they're going to create a range of values around that statistic that we found here to represent the entire population. There is a whole calculation and process that happens to this. This is a lot more involved. Right now, we're just working with basic stuff here. So hopefully that makes a little bit of sense. All right, so next part here is we're going to talk about our variables, qualitative and quantitative. Okay, variables are what we are going to look at. What do I specifically want to calculate or research? They could be things like height, eye color, so many different things here. So just looking at height, we know that everybody is different, okay? My height is different than your height is different than the next person's height. So what we have to do is we have to research a bunch of people so that we can take and find averages or figure out what we expect to happen. So there's going to be lots of different things involved here, and we're going to discuss the types of variables that we can do. Okay, there are two types of variables we are going to work with. Qualitative or categorical variables are going to be describing an attribute or a characteristic. A lot of times these are word responses. So I am female would be a qualitative value about me. I have brown eyes. That is a categorical qualitative value about me. Okay. Quantitative variables are going to give me a numerical value, but that numerical value has to be able to have math done to it. Okay, so there's going to be some times when a numeric value is actually considered qualitative. And I promise we will go through and explain those here, because I'll explain that in a minute here. So determine whether the following variables are qualitative or quantitative. So the first one here is your gender. Gender is going to be a word response. It is, oh, sorry here. So I didn't remember which was coming first. So quantitative remember, are numeric responses that we can perform, adding, subtracting. It makes sense to find their average, things like that. Where qualitatives just describe something about you, are used to categorize you. So gender is a word. It is a qualitative variable. It is describing a characteristic of me. Okay. Temperature. Temperature is a numeric value. Okay. It makes sense with these numeric values that I could average them. I could find a difference between them. It would make sense to find the difference between the high and the low value of the day. So those are quantitative. Okay, temperature is a quantitative value. Next one, the number of days during the past week that a college student studied. Okay, I study 5 days, you study 2 days, Joey studies 3 days. We could average those values to figure out on average, how many days does a college student study? Okay, I could do mathematical operations with that number. So it is quantitative. All right, last one is a zip code. Your zip code is a number value. However, it is used to categorize you and your location. Okay, I cannot find the average zip code for the city of Chicago. It doesn't make sense to do that. Okay, I cannot perform any mathematical operations on a zip code. So it is considered qualitative. Just to give you some ideas here of some other qualitative number values would be a telephone number. Okay, your telephone number tells people where you live or where you did live when you got that cell phone number. So your area code usually tells people what part of the country you are calling from. Your student ID number is a qualitative value. Okay, it does not give any sort of information as far as averages. It's just a number that correlates to you. Other things like jersey numbers. If I look up on a basketball team, it would not make any sense for me to say, what's the average number on a jersey? Okay, I cannot do any calculations. It's qualitative. So hopefully as you kind of work through these, they make a little bit more sense. Again, there's a few numbers that are going to be qualitative. So it isn't always just word versus number. It can be numbers are also qualitative. All right, so what I'm going to do here is I'm going to give you a few seconds to try these, and then I will come back with the answers in just a minute. Okay, so you could pause it here if you wanted to, if you weren't ready yet. We are going to look at these. All right, So your educational level, that is something like I am a freshman, sophomore, junior, senior. I have a bachelor's or a master's or a high school diploma. Those are word responses. It is qualitative. Okay, today's high temperature. This is a number value that I could run calculations on. That makes it quantitative. Okay, next one, daily intake of whole grains. How many grams of whole grains do I take in a day? That is a numeric value that can have calculations run. So quantitative. D, the number of vending machines in a school is a numeric value that I could run calculations on. Quantitative. Okay, whether a student is prepared for class. That is either yes or no. So that is qualitative. Yes or no is a word response. I cannot run any calculations. F, the number of days per week a student eats lunch is a number that I could run calculations on. Quantitative. And the name of the university you attend is word data, so that is qualitative. All right, so hopefully that makes a little more sense here. We'll keep working on these. All right, so from these quantitative variables, we can break them a little further. So number data can be broken into two different groups. So one of those is discrete. Discrete is a quantitative variable that has a finite number of possible values, or meaning countable. Okay, so really specifically, I can count how many there are going to be. There are 5 of them, there are 2 of them. I can count them. A continuous variable is going to have an infinite number of possible values, and it can take on any level of accuracy. So these are usually things that are measured or calculated because I can go to different levels of accuracy. Do I want a whole number? Can I round to 1 decimal place? Do I round to 5 decimal places? Things like that. All right, so what we're going to do next is we are going to look at if the quantitative variable is discrete or continuous. Okay, so you're going to decide, is it discrete or continuous? Can I count the values, or is it something that's being calculated or maybe has some decimals involved here? All right, so the number of heads obtained after flipping a coin 5 times. Is that something I count, or is it something I calculate? That is something I count. So that is discrete, okay? It flips 3 heads. It flips 5 heads. I'm counting how many happen. Next one, the number of cars that arrive at a McDonald's drive-through between 12 and 1 p.m. Okay, am I counting something or am I calculating? Well, I am counting. I would count the number of cars. That is a countable value. Or I could look back and see how many orders were processed through the drive-through. That is a counted value. So it is discrete. All right, next one, the distance a 2020 Toyota Prius can travel in a city driving conditions with a full tank of gas. Okay, this is going to be something that's calculated, because what you're going to do is you're going to run a whole bunch of different tests and be able to average, and maybe I want whole miles, or I could have 1 decimal place of miles. However I want to do that, I'm calculating it, and I can calculate it to different levels of certainty. So this is going to be what's called continuous. Okay, so counted is discrete, calculated is continuous. Okay, so I'm going to combine the two together now. All right, so remember, qualitative versus quantitative. And then if you say data is quantitative, you can now tell me it is discrete or continuous. So let's look at some examples. All right, so gender. First off is gender, qualitative or quantitative. Well, we actually did this one already. That was qualitative. Okay, it is a word response. It's qualitative. Next one, B, income status, for example, middle, low, high. Okay, those are word responses. That is qualitative. Okay, when it just says income, that is going to be a number value that we can run calculations on. So that is quantitative. And your income is a value that is calculated based off of all of your jobs being combined together, expenses, all that. It's a calculated value. So this is continuous. Measurable value. All right, next one. The grade earned in algebra as a percent. Okay, we can work and do calculations with percents. So this is quantitative. Oh, I spelled it wrong. Quantitative. And again, is this a value you count, or is it a value that's calculated? Well, your grade is a calculated value, so it is continuous. All right, responses to the question, working with numbers upsets me. You can give an answer, strongly agree, agree, disagree, or strongly disagree. So you're giving a word response is qualitative. Okay, last one, number of children in the classroom. That is going to be a number that I can run some calculations on. So that is quantitative. Is this a calculated value or a counted value? Well, this would be a counted value. So this would be discrete. All right, so hopefully that makes a little bit more sense with those. And we got one more topic in this section, and then section 1 is complete. This is probably the longest section of this chapter. All right, so, and again, I apologize. A lot of this is going to be definitions. After this, it's a lot more calculations and graphing and things like that, but we really got to get the basics of what all these terms mean. So if you're getting bombarded with a bunch of terms here, please remember to go back to Blackboard and look at the chapter reviews. There's all the definitions broken down, all on a single document. So if some of them are getting confusing, please go back to that. Make yourself a little, Word definition page, whatever you got to do to help make this a little bit more understanding. All right. So last thing we can do to kind of describe these variables that we're working with here is there's levels of measurement. There are 4 different levels of measurement depending on what we have. These first 2 are usually our qualitative variables. So the first one is a nominal, and it's just a name, a label, a category, yes or no, male, female, something like that. Ordinal is the next level of measurement, and it has the word order in it. And this is something that has like a ranking or a hierarchy. So when you're asked to rate on a scale of strongly agree to strongly disagree, that's order. Your grades A, B, C, D, that is an ordered hierarchical system. Okay, so a lot of times these are my qualitative variables. Now, the next 2 gets a little tricky. So one is interval and the other is ratio. Okay, so an interval, it has the properties of ordinal, so there's an order to it, but I'm going to be able to measure the differences, okay? So there's a difference between a 1 and a 5. I can actually calculate those differences. The problem on an interval is that 0 isn't 0, okay? 0 is not the starting value. I may be able to go before 0, or I may be able to go negative, or 0 doesn't mean there's none, okay? So an interval is, I do not really have a starting point. 0 is not my starting point. So a really good example of that is temperature. 0 is not the starting point of our temperature scale. I can go in the negative degrees, okay? So temperature would be an interval level of measurement. A ratio, and the way I remember this is ratio 0. 0 is 0. 0 is the starting value, okay? Age. You can start at 0, okay? There is nothing before 0 when it comes to your age. So I can, I'm trying to think, a lot of these are like your calculated, counted number of children. 0, I can't have negative children. 0 means 0, I have none. Okay, so value of 0 in a ratio level of measurement means the absence of the quantity. We're up here, a value of 0 does not mean I have nothing, and I can go negative up here, or I can go before it. All right, so here's what we're going to do is we're going to try these. All right, so questions we're going to ask ourselves. Does the variable simply categorize each individual? It would be nominal. Does the variable categorize and allow ranking? Would be ordinal. Do differences in values have meaning, but 0 does not mean 0? Interval. And do ratios of values have meaning, but there is a 0 starting point? Is ratio. All right, so let's take a look here. First one is gender. Okay, gender is simply a variable used to categorize yourself, so it is nominal. Okay, temperature, we kind of already talked about that. Temperature, there is a difference in variable meanings, but 0 does not mean 0, okay? 0 does not mean there is no temperature. Okay, I can go negative. So temperature is an interval. C, the number of days during the past week that a college student studied. Okay, it's going to be a number, so I can calculate differences. Can I have negatives here? No, 0 means 0, so it is a ratio. And D, the letter grade earned in your stats class. A, B, C, D. Okay, it's a variable, categorize me, but there is a ranking. A is better than a C. So that is ordinal. Okay, so on the next slide, I've got a few more. So if you want to pause here and try them yourself, and then play it when you're done to check your answers, because I'm going to go right into the answers here. All right, gender again, we already did gender, so we know that is nominal. Okay, so income status, and again, these are all the ones we did previously a few slides ago with qualitative and quantitative. So income status, middle, low, high. Okay, there is a ranking system. It is ordinal. There is an order to it. Okay, your income. Income is a number value of which I can do calculations on, and 0 means 0. If I do not make any money, 0 means 0. Okay. So ratio. Grade earned in algebra as a percent. So here's the difference. A percent is a number value. Okay. This is no longer A, B, C, D. So it is either ratio or interval. So does 0 mean 0? Yes. I cannot have any negative values here. It is a ratio. E, responding with strongly agree, agree, disagree. There is an order to these. So ordinal. And F, the number of children in a classroom. I'm going to count these, and 0 means 0, so it is a ratio. Okay, so that is the end of section 1.1. Tune in to section 1.2 next.